Okay, so on this problem here, we definitely have a challenging type of algebra problem, but I'm actually going to solve it using a system of equations. There's a bunch of different ways in which you can solve it, but I'm just letting you know right from the get-go that I am going to solve this problem using a system of equations, and we're going to talk about how we can do that, right? So let's go ahead and read the problem, and then we'll talk about how to set it up. It says a kayaker traveled 40 miles each way while exploring a river in the Rocky Mountains. So again, going one way was 40 miles, and then coming back was another 40 miles, okay? It then says the kayaker was surprised that the trip downstream only took him 4 hours. However, heading back upstream took him 8 hours. What was the speed of the kayaker in still water? What was the speed of the current? Okay, so this one is definitely a bit challenging when you first take a look at it, and it's not obvious how you're going to set it up. So whenever you have a problem like this here, I like to match up all of my units. And to do that, you want to look at what they're looking for here. They're looking for speed. I can clearly see that right here, right? What is the speed of the kayaker? And then they want to know what is the speed of the current. I can see that right here, okay? So look at the units that they give you. They give you miles and they give you hours. That means my speed is going to be in miles per hour. So miles per hour is going to be my speed, okay? So think about how you can set up an equation based on the units that you're given. And it's not very obvious, okay? But think about going downstream, okay? If you're going downstream, that is going to add to your overall speed, all right? So we know that we want to get the speed of the kayaker. We know that we want to get the speed of the current. Those are my two unknowns. So for example, I'm going to say here x is equal to speed of kayaker, all right? So speed of kayaker, right? That's fine. And then y will be speed of current. And hopefully you can read that, right? But there you go. So x and y is what we're looking for. X will be speed of kayaker and y will be speed of current. And so for my first equation here, we're going to assume we're going downstream. And so I can start off by saying x plus y. And I'm going to say x plus y because, well, here's the speed of the kayaker. We know that the speed of the current will add, right, to the overall speed in which he's going. So we're going to add there, okay, when he's going downstream. Now, when he's going upstream, it's going to be subtraction. So for example, I'm going to have x here, and then that's going to take away from his overall speed because he's going upstream. So minus y, the speed of the current. So now I have x plus y and I have x minus y, right? I'm getting there. Think about what your units are in right now. X and y, that is in miles per hour, right? So x and y, that's miles per hour here. Same thing here, miles per hour. Same thing for this bottom expression here, right? So how can you match it up? Because we know that going one way is going to be 40 miles. So for example, if I set this equal to 40, okay, I have an issue. Because what I'm saying is I'm saying miles per hour plus miles per hour is going to be equal to miles. That is incorrect, right? All of our units have to match up here. So think about what you can do, all right? They did tell us how long it took, right? It took 4 hours to go downstream and 8 hours to go upstream. So think about this logically. If I put this in parentheses here and I multiply by 4, what is going to happen? Think about your units. This 4 is hours, right? I have hours here. So if you were to do hours times miles per hour, because that's what I'm doing inside parentheses, right? Miles per hour. Well, your hours will cancel out and I'm left with miles. Meaning you're going to have miles plus miles equal to miles, right? That's how we want to set it up here. And again, it's not very obvious, but that is how it's going to look. And so I can go ahead and set up the second expression the same way, and I can make it into an equation. So putting it in parentheses, I'll have an 8 on the outside because now we're talking about going upstream equal to 40. And here is your system of equations, and it's actually really simple to solve. So here's equation 1, here's equation 2. Rather than distribute the 4 and distribute the 8, just divide them out. So for example, I can rewrite equation 1 the following way. I could say x plus y is equal to 10 because I'm dividing everything by 4, right? And if I divide the second one by 8, I get the following. I get x minus y equal to 5, right? 40 divided by 8. And so from here, all you have to do is solve for either x or y. Now, these are set up perfect for elimination. So for example, if I rewrite it as x plus y equal to 10, and then right underneath I have x minus y equal to 5, if I use elimination here, the y's are going to cancel, meaning I'm going to add, right? So adding this up, the y's will cancel. X plus x, I get 2x. And then 10 plus 5, I get 15, okay? So 15 divided by 2, that's 7.5. So x is equal to 7.5. And again, this is going to be miles per hour. So that is the speed of the kayaker. Now to get the speed of the current, simply plug that back in and solve for y. Now you can plug it back into this equation here, this one, it doesn't matter. I'm going to go ahead and plug it into this one here because it looks easier, right? You're going to get the same answer regardless, so pick the one that is easiest. So if I plug in a 7.5 into x here, well, I'm going to get 7.5 plus y equal to 10. All I have to do is subtract 7.5 and I'll get my answer. So y is going to be 2.5. So I'm going to write here y is equal to 2.5, and again, miles per hour. That is going to be the speed of the current. And this problem's done. Right, here it is. So that one is definitely challenging, right? It's not obvious at first, but that is how you can solve it using a system of equations, right? So my recommendation to you, always work with the units first and then go from there, because the units are going to help you set up your equations. And by making sure that each side is going to be balanced by using the units, it can make the problem a little bit easier. All right, so that is it. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.